Okay, we're here talking about friction. Now friction is given the formula, the mathematical formula. FR stands for friction. Mu is the coefficient of friction times N. And N is called the normal reaction force. Now the normal reaction force just means the force at right angles to motion. So that's what it means in mathematics. A normal is something that comes at right angles to something else. So if I've got my two pens here and I'm moving them across each other, I'm going to be generating friction between those two surfaces. And there's going to be a normal reaction force which is going to push out like this way. And there'll be one on the bottom because I'm pushing at both ends with my fingers together. And as I move those fingers, the amount of force that my fingers exert to pen determines that normal reaction. And from that formula you can see that the bigger the normal reaction, the bigger the friction force will be. But the other factor that determines friction is this coefficient of friction, which is a measure of the relationship between the two surfaces, the types of surfaces that are in contact with each other. So it's quite simple, really. So if we look at this little diagram here we've got an object just sitting on a flat plane. It could be something like a rubber sitting on a plane like this. I'm looking at it from the side here. And if this was vertical, sitting like that, there will be a gravitational force acting downwards according to the mass of the rubber. And that force, let's just say the rubber weighed 1 kilogram, the surface on which it was sitting was in contact with the rubber, then there will be a 10 Newton force pushing downwards due to gravity, and there'll be a reaction of 10 newtons pushing upwards. And that reaction at right angles to the surface on which the object is going to move is called a normal reaction. Okay. Now here I've indicated a force P, which is pulling the object on this surface. And of course there's going to be a reaction force which opposes motion, because friction always opposes motion, pulling in the opposite direction. So in order to get this object to move, P has to be greater than the frictional resistance force. So you want to find out what that is. Well, there's the answer. Okay, so how do we determine what mu is? I mean, given the fact that N is easy enough because it's just usually a result of an applied force or a gravitational force, what is mu going to be? Well, let's find out. Okay, so if I flip this over here, you might be able to look at that screen. You can see a whole bunch of materials here. This just comes from a Google search. There's the steel on steel. Mu-S stands for mu static, which is the coefficient of friction when the objects aren't moving. Mu dynamic, or mu-K, kinetic, moving, 0.57. You'll notice it's less than the static because there's a certain amount of inertia, but once it's moving, it's actually easier to keep the object moving. You'll have less frictional force once it's moving. And you can see copper on steel has less. Let's find one that's really sort of low. Look at that, Teflon on Teflon, 0.04, very low coefficient of friction, sort of indicating that Teflon's a great frictional surface, non-friction surface, non-stick surface. So 0.1 ice on ice, well, that just experience tells us that that will be the case. Okay. Alright, so let's get back onto here now. Alright, so let's have a quick think about now, how do we develop mu? How does it happen? Well, it's done by placing an object on a sloping surface like this, and by raising the surface up until this object here, whatever it might be, is just about to slide down the surface. Now it's assumed that the object has a mass, and that mass is, say, whatever it is. Let's assume that the mass produces a weight called W. So W is the weight of that mass that's sitting on the sloping surface. So it's going to be the kilograms times the acceleration due to gravity in newtons. So W is going to be in newtons. And then it's going to have a normal reaction. Now the normal reaction force will always usually be at right angles to the surface. So it's a right angle there. Normal reaction. And because the motion's happening along this plane, it's basically the same situation as up here, except we're turning it now on its side. And then we're going to have friction, which always opposes motion. So friction is going to go uphill. And then we're going to have well, what's pushing it downhill, you ask? Well, it'll be the component of the weight force that acts down the slope. That's this component here. Okay, so there's the weight force pushing down here. I'm now breaking this weight force up into two vectors. One which is at right angles to the sloping surface, and the other vector is parallel to the sloping surface. Yeah. So I've changed W into two vectors, one which is at right angles to the sloping surface, one which is parallel. So this one over here, if we consider this angle to be alpha, it could be theta or delta, any angle we want, and we say that at this point alpha is the angle at which the object is just about to move. The object is just about to slip. So it's not quite slipping, but it's just about to slip. Why is that so useful for us? Well, it means that we can use the equations of equilibrium and know that we're at the maximum frictional force that we can possibly have. So using the equations of equilibrium, remember that the sum, that just means sum, the sum of all the forces that are vertical has to equal to 0. So in other words, all the vertical forces have to be equal to 0. The sum of all the forces that are horizontal has to equal to 0. And the sum of all the turning moments has to equal 0 if the object is going to be stationary or moving with constant velocity. That is equilibrium. So these are very powerful equations or means by which we can generate equations. And the equations means that we can then control what's going on. So okay, so if the sum of all the vertical forces, well, I'm now going to consider vertical to be here now. I'm going to take my point of reference along the plane surface and not the horizontal surface. Why is that? Because it means I only have to change one of these vectors into horizontal, into vectors which are perpendicular and horizontal to the plane. If I was going to keep my plane as horizontal here, I'd have to change this frictional resistance force into vertical and horizontal components. I have to do the same to the normal. That's more work. I'm just going to change my frame of reference. So now I'm going to make this sloping plane to be horizontal. Yeah, just tilting my head. So if that's the case, this angle inside here is also going to be alpha. Why is that? Well, if that's a right angle, then this is going to be 90 degrees between these two. This must be 90 minus alpha inside here. And then if I look at another triangle, this one triangle here, from here to here to here, and that is a right angle just inside there, there's a right angle. Then if this angle here is 90 minus alpha, I have to add the alpha back in to get the right angle. That must be alpha. That means that this little force acting down the hill using trigonometry is going to be W, which is the hypotenuse, W sine alpha. This one over here will be W cos alpha. And the reason for that is because in this triangle here, one that I'm touching, down to the tip of the W and across to here, this triangle here, sine of alpha is equal to this side divided by W. If I multiply both sides by W on that equation, I'll get this side here is W sine alpha. And I can repeat the process for this side on that here. Now I generate those two equations. Okay, so now let's look at all the forces which are vertical at right angles to the plane. So I'm going to do sum of the forces which are at right angles to the plane. And I'm going to make this direction positive, right? Upwards positive. They have to equal 0. So here they are. I have N minus, because this other force, W cos alpha, has to equal 0. They're the only two forces that are right angles to the plane. Because remember, I've changed W and I've made it into W cos alpha and W sine alpha. Right. That means, therefore, N is going to equal to W cos of alpha. So there's my first equation. Call it 1. Now let's sum all of the forces which are parallel to the plane. And I'm going to make uphill positive. they have to equal 0. So there's the forces parallel to the plane here. Now, there's only two of them. There's FR and there's the other force W sine alpha going down the plane. So therefore, FR minus W sine alpha equals 0. Taking that equation and placing this the W sine alpha on the opposite side, so adding W sine alpha to both sides, we're going to get FR equals W sine alpha. Now there's my second equation. Now, tan of any angle, let's say alpha, is going to equal to the sine of that alpha divided by the cos of the alpha. Now why is that? Well, because sine of alpha is always the opposite divided by the hypotenuse, and you're going to divide it by cos, which is the adjacent divided by the hypotenuse. If you divide those two together, the hypotenuses will cancel out and you'll just get opposite divided by adjacent or next door, and that is tan of that angle. Okay, so that's the reason that's true. So if I divide equation number 2, which is true, divided by equation number 1, I'm going to get n, or I should say FR, there it is, FR divided by n is going to equal to W sine of alpha divided by W cos of alpha. I've just divided these two equations together. They are both true, and if you divide a true thing by a true thing, you still get a true thing. W's will cancel out. Sine alpha divided by cos alpha is just simply tan alpha. So therefore, FR divided by n equals tan alpha. And if we make FR the subject of this equation, FR equals tan alpha times n. And of course we know right from the top here that FR equals mu n, therefore tan alpha equals mu at the point when the object is about to move. That's very important to note. So it's a case of limiting friction. Does that make sense now? So have a think about that, and that will tell you exactly how to solve any problem when you want to know an object is going to move. So all you need to know is the mass, you need to know the coefficient of friction, and then you can determine what the slope will be before the object starts to slip. That's very handy to know that. Bye now. Hope that helps.